Welcome to this presentation on image, pixel, image resolution and file size, made simple. In this short video, we will understand what a digital image is, what a pixel represents, how image resolution is specified, and how the uncompressed file size is calculated. This presentation is presented by Professor Gottapu Sasibhushana. A digital image can be considered as a two-dimensional array of pixels, arranged in rows and columns. In the figure, the horizontal direction represents the x-coordinate, or columns, and the vertical direction represents the y-coordinate, or rows. Each small square is one pixel, or picture element. A pixel has a location, x, y, and an intensity value. For example, the highlighted pixel in the figure has an intensity value of 79. For an 8-bit grayscale image, each pixel can have 28 is equal to 256. Possible intensity levels, ranging from 0 to 255. 0 represents black, 255 represents white, and intermediate values represent different shades of gray. Therefore, a digital image is essentially a matrix of numbers, where each number represents the brightness of one pixel. Now let us relate the number of pixels to image resolution and file size. In the first figure, the image has a width of 256 pixels and a height of 256 pixels. Therefore, its resolution is 256 times 256. And the total number of pixels is 256 times 256 equals 65,536 pixels. Next, consider the bit depth. For an 8-bit grayscale image, each pixel requires 8 bits, which is equal to 1 byte. So, the uncompressed file size is calculated as file size is equal to W times H times bit depth. For this example, 256 times 256 times 8 is equal to 524,288 bits. This is equal to 65,536 bytes, or approximately 64 KB. So the important point is, resolution tells us how many pixels are present, while bit depth tells us how much information is stored in each pixel. Together, they determine the uncompressed image file size.